Yes.
Somebody falls on the beach and woke up with the hideous.
Alright, let's see if we can do this.
Man.
Why is... Oh, there we go. Alright. I think I got all the glares taken care of. I got my markers tested. Yeah, thank you. You're a special, special kid. All right, gamers. There, that should work better. Ooh, we're up to 10. Exciting. There, we're still a little early, so we're going to wait to see if anybody else shows up. Otherwise, just the 10 of you. Ooh, 9 of you.
Ooh.
What did I do? There is a bit of a delay between what I'm streaming and what I'm doing and what's coming out on YouTube. So if I miss your question, obviously say something. But outside of that, I think we will be set. Just go ahead and ask things in the stream. I'll be checking it from time to time as we go through the problems. And my freshman in the background is doing calisthenics.
Hello there.
Hey there, gamers!
Oh my.
We're going to show you how to get more TikTok followers. What is the delay on this? And what did I put in to do that? I'm just going to check something here real quick and then we'll output video. Yeah, go ahead. Video. Stream delay. I don't want to have a stream delay. I know this is riveting, ain't it? Closed captions, don't care. By show of hands, how many people are saying, oh, wow, watching a boomer try to do live streams is fun? You? Shush. All right. All right, well, let's just go ahead and jump in and get started. Couple things to remember as we go through this. We're playing around, we're kind of doing almost math trivia. We're kind of walking your way through some things. So just as a reminder, and I think I said this in one of the videos, either you watch Monday or Wednesday, you should be watching out for, you should have like one sheet of paper. I know oftentimes, at least in my class, I say write it over in the margins. There's going to be enough stuff going on that it's good to have just like one sheet of paper where you write stuff really, really nice. And it looks amazing. Brooklyn, I'm talking to you. But anybody else. And so, like, for example, you've got, okay, so cosecant theta, what's that equal to? Right, 1 over sine. Secant theta is 1 over cosine. Cotangent theta is equal to 1 over tangent. Just so you have those in the back of your head. Ben says, 12 people waiting on you. Yeah, thank you. I think I'm there now. The other thing that we got here going is this. And my other question is, where are you really going to go? I mean, I know there's other YouTubers out there. And by the way, hit subscribe and smash that like button. If you have a chance, click on the little bell. Anyway, so then there's the Pythagorean identities that we have to worry about. Pythagorean identity has this. Okay, there are two other identities that go on, and one of the things as we go through trig identities that you should probably consider is that if you see two squared identities together, you got to be thinking, how can I turn that into a 1? Or if you've got a 1 and a squared identity, that, hey, I can turn that into something else. I can combine two things into one. Because remember, if I go through and I divide these all through by sine squared, what does this turn into? This becomes a 1 through and divide these all through by sine squared plus cosine squared is equal to 1. And remember that you can divide them out to get, for example, in this case, tangent squared plus 1 is equal to secant squared. Then you don't necessarily have to memorize these two. And that's one of those things that we try to do. Okay, I can see that. That's one of those things that we try to go through and teach you guys, that just purely memorizing things is not going to be your best option. That if you know how to derive things when push comes to shove, if you get stuck, then you can go from there. Okay? These are going to be the things that we're going to be using quite a bit in these 5 problems. Elizabeth Kimberly says, could you save this live stream so we can look back at it again later? Yeah, in fact, that's the beautiful thing about doing YouTube Live, is that we will go ahead and it will automatically be cataloged and saved right here. Same URL. Okay? So, yeah, I totally get that, and especially if you're in my class, you know that I can talk really, really fast sometimes, and I get really excited. So, what, Zoomer? Anyway, so that's what we're going to be working with. Now you can see the first problem already up there on our screen. So let's talk about, my goal here is I want to talk through this, kind of what my strategy will be. A couple of reminders. Sometimes there are other ways to make this work. So for example, the strategy that I use may not, dare I say, even be the best strategy, but it's one way to go, and I'll try to talk through some of the other possibilities. But these first ones that we're doing right now, pretty straightforward. So, problem number 1. Tangent theta plus cotangent theta, and we want that to go to 1 minus cosine theta sine theta. Okay? Now, the big thing here to remember is this. You can never set these two things equal to each other. We're trying to show, and actually what we're going to end up doing probably when we get back to school after spring break, is what we're trying to show, we'll try to show that that two things are equal, but until you prove that the two things are equal, you cannot put an equal sign in between them. All right? So here, we're trying to get from here to here. Now that does not mean that you don't play around with this side and maybe work backwards a step or two. But what it does mean is that sometimes you'll see people on YouTube where they'll just put this is equal to this, and they'll start moving things to both sides and adding things to both sides. And the mathematical laws that you're breaking there is awful. People will make fun of you at parties, all of that. So anyway, first thing that I'm noticing is this. I've got 2 terms here. I have 1 term here. So somehow I need to combine these things together. The other thing that strikes me here is these are both quotients. I can rewrite this, and the other thing too is that, look, I've got sine and cosine down here. So that means I need to probably turn these into sine and cosine here. So this is going to turn into sine theta over cosine theta plus cosine theta sine theta. So now I've got what I'm at least in the ballpark. I have what I want. I've got cosines and sines down over here. Get this out of the way. So now the bigger question is, how can I combine two fractions together? Think back, 5th grade maybe, middle school. That's right, common denominator. Yay! Now check this out. So your common denominator is going to be cosine theta. Wow, that's an ugly theta.
Let's go 6.
You know what? I'm not like Mr. Vokes. I have not invested in a 4x8 dry erase board to fix to my wall in your house.
Doesn't mean that you have an excuse for not being able to draw.
All right. That's enough out of you. Sorry. All right, so anyway, so this side over here, I'm going to multiply this by sine over sine. And this side over here, I'm going to multiply by another 6. Good job. Cosine over cosine. Now this next step, so then what's going to end up happening is this is going to equal. Now notice I've got my common denominator. Yes, I know they're not in the exact same thing. You guys are smart. You can swap. Multiplication is commutative, so you can put them in either order. I'm going to go ahead and put cosine theta sine theta. Oh my goodness, without even trying, just by simply trying to put these two things together. Hey, we already have the denominator the way we want. Check. One achievement unlocked. Notice up here, now here's the other thing that sometimes people will do. They'll be like, oh, but now I can cancel those out. No, we don't want to cancel those out. We're trying to bring them together. So now notice, sine times sine is going to become sine squared theta. Some people sometimes will ask, why isn't it sine theta squared? This... Okay, you're not squaring the theta, you're squaring the sine, and that's why that's going here. Okay? So anyway, I digress. So once again here, sine squared theta, ooh, remember, when you start seeing functions squared, you start thinking, ooh, I can start using those. Can maybe equal to 1, move things in. Cosine times cosine is, hey! Now there should be a little bell going off in the back of your head. I have 2 squared trig functions. That means I can maybe make it into a 1. Guess what? Pythagorean identity, sine squared plus sine squared plus cosine squared is equal to 1 over cosine theta sine squared theta. So we put a little check mark here because it's done. Now, if you really want to get snooty here and nerdy, and I know some of you do, you could put a little QED at the end. Quod erat demonstratum. So it's been demonstrated. Basically, it's kind of showing, it's like, yeah, it was easy, you were fine. But that's up to your own personal teacher. All right? Pause here for a second, see if anything's here. From the feedback I got yesterday, sorry for shaking the camera. Let me try this. Move the table back. Hey, there we go. Feedback I got yesterday, this seemed to be pretty good for most people. It was some of the later ones that they were having issues with. All right, so let's do this. Move on to the next problem. All right, no questions. Let's do number 2. So, hopefully none of you guys went to the playground and started looking playground equipment. I've heard that that's bad. All right. So, question number 2. So I've got 1 plus tangent squared. Just be tangent squared. Oh, no problem. And I know some of you guys are just thrilled to see the inside of a teacher's house, that I don't actually live in the basement of the closet in my classroom. All right, so a couple of things. Now, again, we're trying to get, now notice I've got 2 things here in a quotient. I'm trying to go down into tangent squared. Now, the back of my head, I should be going, ooh, tangent squared. I think I could write this somewhere else. This might be a good idea to have that. A couple of other things. If I look up here, notice I've got ones in squared terms. The bell's going off in the back of my head again. I should be going, what Pythagorean identity should I have? So now notice here, on page 642 of the wonderful textbook we give you, Mr. Hayes, I just take, don't worry about it. So it's right here. So over here in my play area here, we're going to say, all right, hey, look, this is really equal to, and sometimes going horizontal is nice, sometimes going vertical is nice. There's not necessarily a good way to go through and do it. Tangent squared theta is really equal to secant squared. Nice. 1 plus cotangent squared is equal to cosecant. Now, by the way, your teacher, whoever it was, probably yelled at you because some of you guys might be wanting to go, oh, can't we get rid of the squares? Can't we get rid of the ones? No, it's not how it works. 1 is not a factor. It's 1 plus something. It's an addend if you really want to know. You just can't divide that out. You can't get rid of the squares. It doesn't work that way. What? I'm working here.
Yeah, I need help with paychecks.
Later. Children. You know how it goes. You're on the other side, hopefully. All right, so anyway, so now here we've got this. Now the benefit here is I've got 2 terms into 1 term, 2 terms into 1 term. So we're already kind of getting there. Now the other thing that you should be thinking about, now remember, if we did, the question is, how can I turn secant squared and cosecant squared into sine and cosine? Wait a second, they're reciprocals. Now, for sake of ease, I'm going to break this up. So this I can rewrite like this. So technically that's secant squared over 1. Cosecant is on the bottom, so I'm going to do it like this. And I'm doing it like this because oftentimes if you're having a hard time seeing what's going on, it's easier to see the flip. Secant in the top, remember the reciprocal of that is cosine. They're cousins. So 1 over cosine squared. This one has a cousin too. It's called sine. Ooh. Hey, we're almost there. And then from there, we can obviously just move this back together. Now, I hear some of you screaming at the computer, saying, whoa, couldn't I just have gone from here to here? The answer is yes. However, I would not start there because particularly if you're having a hard time learning how to play around with this, this is probably going to be helpful. So anyway, so we get down to sine squared over cos, so anyway, seriously though, we've got sine squared over cosine squared. Sine over cosine is tangent. So sine squared over cosine squared is going to be tangent. And then, because we're snobs, not just snobs, we're math snobs, we're going to say check Q, E, D. The other thing, to be perfectly honest, the reason why you need to do this is that you're signaling the end of what you're doing. Okay, you're saying, we're done, it's over, don't worry about it, you don't have to worry about, hey, are there any more steps? In other words, it's a lot like what you guys want me to do in the classroom. Sometimes you're like, wait, are we done? I'm like, yeah. Boom, we're marking it, we're done. Okay? Questions, concerns, panic attacks. While I wait for the leg to catch up to see if anybody types anything. That's enough out of you. Anyway, how many movies have you guys watched? I'm going to put the over-under at 6. Sorry, just Nerf darts are flying in. Hi. Armando, hello. How are you doing? Do you want to come say hi?
No, I'm fine.
Okay, just
I
checking.
was grabbing the dart. Come on.
All right. So, all right, let's try number 3. Now we're getting into the territory where people are starting to go, wow, why did I sign up for this class? And that's okay. And to be honest, with trig identities, we spend 2 or 3 days on this first part in the live classroom, and then we probably spend another week messing around with trig identities, which is going to be like the next step when we kind of get away from these simpler ones. I know what you're thinking. Oops, I need to change the problem. Come on, Boomer. Even though I'm Gen X. All right. But anyway, seriously, we spend at least a week going through some of these things because a lot like the unit circle trig, you can't just sit there and assume that you're going to learn it and go. Okay, you really kind of have to play around. Oops. Alexa, how do you get from tangent and cotangent to sequel, sine, and cosecant? All right, so the way that you do that is this. At the very beginning of the very beginning of the video, there we went through how, and you can turn this on page 642, that 1 plus tangent squared is equal to, what did we say, secant squared? And the way that we do that is we're starting off with this one here. And then, as the video showed you before, how is that still saying video problem number 1? That's disappointing. Give me 1 second here. Oh. Sorry about that. I didn't realize I had to hit transition. Anyway, on with the countdown. So what we end up doing is we're taking this, the Pythagorean identity. Remember, that was taken from, we have the unit circle. We've got this. We came up to a point of saying, okay, this is my cosine side because that's the adjacent to my angle. This is my, if this is theta, this is my sine. So then therefore, since this is 1 by Pythagorean identity, cosine squared plus sine squared is equal to 1. That's how we came up with this. And then we said, hey, it'd be really useful if we could turn it into other trig functions. And so by doing that, since they're all reciprocals or ratios, we did stuff like that. So again, make up a sheet of paper with all of these on there. It's important for you to write them out because if you don't write them out, it's just not going to stick. And just have that with you every time. If you really are good, if you have a piece of maybe cardstock, make it look really nice. Type it all up. I mean, and don't type it up. Write it out. Maybe you want to type it up, and it doesn't matter. You do what you guys want to do in terms of that. But seriously, do it on a separate sheet of paper. Nice notes is always good. Better yet, notes you can read notes that you make yourself that you can read yourself. Even better.
Nah.
So here we go. So problem number 3. See, now it's down on the bottom, right? Oops, there.
Now it's not.
So we've got this. We've got 2 binomials being multiplied together. What page again, Vincent? Vincent says 642. Fundamental identities. Fundamental. If reading's fundamental, these are fundamental for math. 642. Got it? So. Alrighty, so problem number 3, secant alpha. That's what the little Greek fish is called. Cosecant alpha. Your book has it, if it's in a Greek letter, it will actually, that means you're talking with angles. If it's with a Arabic letter, then it, A, B, or C, then you're talking about radians. It's always going to be the same setup. So we're going to go from there. So we got this giant down to a different of this. You're going to have sine alpha plus cosine alpha squared over sine alpha, cosine alpha. Now, before you ask, no, these don't divide out. No, 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 no. Okay? You're adding here. You're multiplying down here. It doesn't. You can't divide it. No, no way about it. However, we are going to come up with some stuff in terms of quadratics that you should know in the back of your head. So for everything that you forgot about first semester is going to come back and nip at your heels here a little bit. Might even bite your hand. Be careful. Review that. In fact, hey, Mr. Vokes, Thornton, Perez, if you guys are watching, let's put this in the review for next week. Anyway, so which one looks more complicated? They're about the same. But up here, I've gotten two binomials, which I need to multiply together. Down here, however, I've got all this messed up. Now, the one thing in the back of my head, if I square this out, okay, remember, if I have, we can do this in a different color. So remember back, actually I'll do it over here. Remember back to semester 1. You might have something like this. And some of you guys are like, that's easy. It's a squared plus b squared. No, it's not. No, it's not. It is actually a squared plus 2ab plus b squared. Because remember, this is, if you square something, you're multiplying it by itself. I get a squared, I get b squared like you want. However, I get these middle terms here. I get an ab and an ab. So I get 2ab. This should be something that you just know and love. As an honor student, seriously, it's like factoring a squared minus b squared. You should just do it. Period. Done. Know it, learn it, love it. Because we can't explain it every single time. But now that ends, since you're sitting over here, you're going to be like, wait a second, if that's squared, that means the step prior to this is probably going to look like this. I'm going to have sine squared alpha. I'm probably going to have the double of the product. So 2 sine squared alpha cosine alpha plus cosine squared alpha. So when I multiply all this stuff out, we obviously still have to get to a fraction. And some of you guys may already be thinking, wait a second. Secant, cosecant, I can write those as fractions. Good, we're going to get to you in a second. However, this is probably going to be my numerator in the step prior to this. So let's multiply this out. If I multiply this out, I will warn you it's going to look messy. I will also warn you it'll be okay. So secant times cosine. Now some of you guys might be saying, hey, isn't that just 1? Yeah, for right now, we're just going to leave it alone. Sometimes trying to take shortcuts is not terribly helpful. Plus secant times sine plus right here, when I multiply this out, I'm going to get cosecant times cosine. And then the last one I'm going to get is going to be cosecant times, missed a plus. Now I can hear you muttering in the back of the room. I should really move this to the other side. Actually, I'll do that here first. Anyway, it doesn't matter. I can hear some of you guys muttering in the back of the room, hey, why don't we... Or actually, Mr. Hayes, you said that this was going to be easier. This is going to be simpler. We're going to get there. But again, don't oversimplify this. Because again, remember, we're trying to turn all of these into a single term. If you're turning this and this into ones, that's not going to help us. We're going to need to turn all of these into fractions and combine them into one thing. Here we go. Secant is really 1 over cosine, right? So this is going to become cosine alpha over cosine alpha. Because remember, this is that. I'm going to move my chat page here a little bit closer. This over here, secant again, is still cosine. So now this is going to be plus sine alpha over cosine alpha. What is this going to turn into? Oh wait, I did that one wrong. Who was yelling at me for that? I'm sorry I missed you. So secant times cosine, secant times sine, this would be cosecant. I know I've let you down. I'm sorry. I know you don't usually hear apologies from, figures these days, but anyway, so we're going to keep on going. So this right over here, this is going to become plus. This is 1 over sine, remember? So that means that this is going to turn into cosine alpha over sine alpha. And last but not least, this is going to turn into, for the same reason, cosecant is going to be turned into a sine in the denominator. Now, I know every fiber of your being wants to turn this into a 1 and this into a 1. I'm going to tell you why not. What is our denominator here? We want sine plus cosine, right? So, this over here, if I put these together, I'm going to get cosine alpha plus sine alpha over cosine alpha. Over here, I'm going to get cosine alpha plus sine alpha over sine alpha. Now what? That's a good question. So you got a couple of different options. We're close because we've got these two that I want here. I want to be able to multiply this out. Let's take a step back and take a look at what's going on here. Okay? So if I were to break this down, okay, I would have, so each one of these would be over each one of these denominators. And I am getting stuck for some reason. I know, this is riveting. Riveting. That is plus on the bottom. Oh, that's why. That's supposed to be times. That would make life so much easier. When in doubt, check the original problem. Okay, so now, much easier. Thanks again to you yelling about that. So where are we at? So what you're going to end up doing here is now it falls apart. Oh, look, I need sine and cosine in the denominator. What do I need here? Oh, I'm going to need a sine in the denominator. Also remember here in a previous step, we need 2 sine times cosines. So if I multiply this out, I'm going to get sine alpha, cosine alpha here. Since this is in parentheses, I'm going to distribute this out. So I'm going to get sine alpha cosine alpha plus sine squared alpha. We now have half of what we need, because remember the step prior to the ending is we need a sine squared. Check, I have that. I need 2 sine alphas, cosine alphas, and I have 1 of them so far. And you can probably hopefully see where this is going. Because now I'm going to multiply this side through by what's missing from the denominator. Cosine, so I'm going to say, okay, I'm going to multiply that by cosine alpha over cosine alpha. So that's going to be plus. So now I'm going to get my cosine squared alpha. plus, I'm going to get another sine times cosine, which I want right there. So anyway, so cosine squared, I have that. Now I have this. Now I've got my common denominator. So then all of that, pardon the tape here on my dry erase board, that's what you get when you have a dry erase board easel for your children from about the age of 4 on. Homemade, by the way, my uncle did that. Do I need a secret word for today? Maybe I should. So I get my sine squared from there. I got this, and this is going to go together to become my 2 sine alpha cosine alpha, plus, and then I get my cosine squared alpha, and then that goes straight to the end. Okay? Nobody is answering. So yes, if you felt a little intimidated by the one, that's totally understandable. This one and 5 are probably the 2 hardest ones. I fully expected, to be honest, that we was having a fair number of people taking a swing at the first 2. And then 3 and 5 would be the ones that cause the most headaches. So, questions, concerns, smart remarks, favorite celebrities on Instagram in quarantine. All right, so let's change that over. And I'll erase this. I'm just going to get the next one set up. Ooh, one from 18 to 17. Not bad. Especially since you can rewatch this. And this is always much more fun than like watching your Sox game or Cubs game on a replay. However, I did hear the NFL on demand and the NBA on demand now for free will allow you to go watch past games. So you don't even have to have the subscription to go back and look at the catalog. So if you're interested in either of those, you can do that. Universal releasing, The Invisible Man early, and for as mere $20, you can watch it at home instead of in the theater, which seems a little steep. I suppose you got potential for multiple people, but we'll see how that goes. All right, problem number 4. Where are we at? How long have we been doing this? 36 minutes. You guys deserve an achievement if you've been here since the
I
beginning.
would say, how can you stand this guy for that long?
How can you stand living with that guy for so long?
Exactly.
All right, so problem number 4, as you can see down the bottom of the screen. So I've got sine theta plus cotangent theta cosine theta. I really do kind of like this in 6s, don't I? And we're going to try to turn those 2 terms all the way into a simple cosecant theta. So, thoughts, take a second. Ask yourself, well, what are the different ways I could combine these things? Sine, and I think one of the steps I gave you, if not, it's going to be when we go through it again, is that when in doubt, if you get stuck, you can change everything from sine, everything into sine and cosine. So in this case here, sine's fine, cosine's fine. We're going to have to want to play with the cotangent. Back of your head, cotangent is cosine over sine. Ooh. Cosine over sine. That means I get a cosine squared. I also get a sine in the denominator, which means that I can combine them into using fractions. I know. So, let's get to it. First things first, let's break it down. As long as I don't knock over my water. We do not need instrumental music, my friend. So, so I'm going to rewrite this. This is going to become sine theta plus, this is going to be cosine theta over sine theta times cosine theta. Now, Could you write that as cosine squared over sine? Cosine squared theta over sine theta? Yes. I'm going to ask you to leave it like this, because that's going to allow you to show to your teacher, hey, I know what I'm doing. And I'm not just blindly pushing through. It's going to cost you an extra 10 seconds of writing by the time we do that a couple times throughout this. You've got the time. You'll be fine. Any questions? No? Okay. So anyway, so this is going to be, so now at this point, this is obviously going to become cosine squared theta. Oops, not sine squared theta yet. Sorry. And over here, sine theta. Now again, how do we combine two terms into one? Especially if you have a fraction, common denominator. The common denominator in this case, good old sine. So that's going to end up become sine squared theta. Uh-oh, bell's going off in the back of your head again. Over sine theta. No, you may not divide these out. But what you can do, sine squared theta cosine, oh, that's 1! I know! See, it just kind of starts falling together.
It just works.
It just works. Thank you, Elijah. It's just like when you're playing, I don't know, Fortnite and, no, I don't know. I have no idea. Overwatch, yes. Fortnite,
Boomer.
not so much. Anyway, over here, so that means that this, by Pythagorean identity, because remember, sine squared plus cosine squared equals 1. That's going to equal 1 over sine theta. And that immediately goes into cosecant squared. Check. QED. I forgot to do that on number 3, didn't I? I'm sorry. I know that you deserve better.
Yeah, you're like my teacher.
So, no, granted, it's a little thing, but I understand that some of you guys may not have seen that we were actually done. That's okay. Zoomer. Yeah, that's the little guy. Little guy being somebody who's only a year younger than you guys. So, anyway, questions, concerns, panic attacks. Question number 5. If you got question number 5 on your own, you've got some really good skills. There's a couple of tricks in there that you got to be careful of. So, I'm going to go ahead and erase this. Let's transfer this over. Now, while I'm erasing this, if some of you guys need to go get some tissue because you realize that this YouTube Live is coming to an end, that's okay. I understand it's emotional. Some of you guys might be tearing up. Some of you guys might be emailing your counselors right now saying, get me out of this class. Yeah, that's fine. So anyway, here we go. So, a couple of thoughts here just as I'm looking at this. I've got here, and I'm turning into here. So I've got a binomial squared, so I'm going to want to square all of that out. And then I'm going to have to mess it here. Now remember what I said early on. If I've got two terms, both of which are squared, I got to think that these are going to have ones involved somehow. We're going to have to go back to those Pythagorean identities. And so we'll talk about that here in a second, but once I get it set up, we'll take a step back from each of these two terms here so that we can kind of get a sense of where we're going. All right? So, number 5, cosine A plus secant A squared. We're going to try to get that down here to tangent squared A minus sine squared A. Now, if you look at what's going on, one of the things that sometimes I will have people do, pull out the blue. If you look at the page, or if you remember what's going on, okay, remember we've got this. Sine squared plus cosine squared is equal to 1. So if I want tangent, that's going to be sine over cosine. So I'm going to take all of these divided through. So that means that this is going to become, sine over cosine is going to become tangent squared. Divided by cosine is going to become 1, and this is going to equal secant squared. Should put a little a's here. Right? This divided by cosine is this divided by cosine squared is 1, this divided by cosine is secant. So since I have a lone tangent squared down here, now notice sine squared isn't any part of this. Okay? So what I need to think about that this is probably going to be coming from, because here if I want the tangent squared, I can subtract 1 from both sides. So this is probably going to do something like this. It's going to look like secant squared a minus 1. So I need to have that in the back of my head. I need to hopefully find, oh look, I have a secant. I'm going to square it, so I've probably got the secant squared part already taken care of. But somehow we're going to have to get 1 introduced. Now same thing here, notice sine, I have a minus sine squared. So over here, if I want this to become minus, a couple of things. Where'd they go? You got a couple different ways to do it. Probably the easiest way to go through and do it is this. I can swap these, right? I can subtract the sine squared from both sides, so I'm going to get minus sine squared over here. I'm going to subtract the 1 from both sides. Yeah, you can take the power. And then this will just become, so I'll have the cosine squared over here and I get minus 1. If you're not sure what I did there, subtract sine from both sides, subtract the 1 from both sides. So I want to get it to this. So this right over here actually is basically cosine squared minus 1. Oh look, I already have a cosine up here. So when I square this out, I'm going to get cosine squared. So I just have to figure out how do I get minus 1 twice. So we're going to get there. So let's go ahead and get back up here. So again, trig is that type of thing. Armando, why, wait, plus isn't it minus? Armando, which part are you talking about? Well, I'm waiting for Armando to respond. I'll continue on with my thought. One of those things is that if you're talking about these down here, it's because what we ended up doing was you're isolating a particular part of the trig identity. And I can go through that again, because it is a little tricky. But one of the things you're going to learn, particularly in trig, is that sometimes you can't just plow straight into things. You really kind of have to think your way through things, because if you don't, you're going to end up in parts that you're, if you drive right now, it's kind of like if you're going too fast, you miss a turn, and sometimes you don't even know that you missed the turn. You just are going along, you're driving down the street, and you're like, where in the world is the exit, or where's, Joliet Street? Not knowing that you passed it 3 blocks back. Because you're on your phone, you're talking to somebody, whatever. And so if you miss stuff, the problem. Up here, let me check. Oh, good call. I wrote it down. You get bonus points. I will give you 2 favorite student points, and Armando, I will give you 2 points in your English class for a good copy editing job. I mean, it's even right there, Hayes, right? You know what, Alexa? I hear you. And you know what the problem was? When I copy down, this is how the sausage is made, okay? So over here on this little table, I had the problems that I needed to write up, so I didn't have to squint. But my problem was that apparently I wrote it down wrong. I'm sorry, okay? I realize that when your heroes let you down, it hurts sometimes, okay? It happens. But the best part is we got it fixed, and that's all that matters. So, moving on. All right, so here's the idea. Original problem. Fixed. This matches with what we have down here. Ending matches what we have down here. So this is still valid. This is still valid. And away we go. Okay? Oh, Armando, I totally get it. I am so sorry. I'm glad you said something, because I would have gotten in the middle of all this other thing, and I would have been like, what in the world? Why do we have +2? And then I would have said, oh, it should probably be -2, and then I would look and just, So, here we go. With a flourish. By the way, this is why another reason why I can't run for president is because we have this video evidence of me just going off the rails. So we're going to multiply this out. This is going to square out. If you're not sure what I'm going to do here, I'm going to ask you to do this. If I asked you to square that, what would you get? This squared, because again, remember, one of the things in my class, we say, when in doubt, make it into a simpler problem. This squared out is going to get you this, which is why Armando's catch is so important, because now notice I've got a minus here and not a plus. So this, so I'm going to get 2 of both of those multiplied together. Cosine secant, and then plus secant squared elbow. All right? No, seriously, Armando, 2 points English. Whoever your English teacher is, let me know. I'm sure he or she can give you more points. If nothing else, you can be a student assistant next year and you can just double check that I'm not screwing something up. All right, so now notice here. Let's go back to our little checklist. Down here, I want a cosine. Hey, cosine squared. Hey, I got that. I need a secant squared. Hey, I got that. So now the question is, how do I get -1 and -1? Now, you may already be yelling, wait a second, wait a second, wait a second, wait a second. This is really cosine. This, remember, is that. Now, you can't actually write that down because that's just not how mathematicians do things. But since they're reciprocal identities, this is going to equal 1. So now I've got cosine squared A, or cosine squared A -2 plus secant squared A. But Mr. Hayes, Mrs. Cullen. Okay, we'll see what we can do. No promises, but she has favorite student points. We'll see what we can do. Anyway, so we're like, but Mr. Hayes, we need -1s. What am I going to do with the -2s? And then, oh. See, this is why, and again, being methodical is the right term, just kind of going through and just being consistent with it is important, because now what you can do is I can break this down. I can say, okay, that's equal to cosine A -1, because -1 is -2. So if I break this down, I can take one of them for the cosine, so I can get my sine squared. And I can take one of them for my secant squared, and I can get here. So this is going to turn into tangent squared A. And this is going to turn into -sine squared A. And then you just have to reverse it, because otherwise people cry. But again, that whole idea of looking back to see what the previous step is, just unfocused? No, okay, this is my eyes, it's okay. But taking that one step back to kind of get a sense of where you're going sometimes is really, really important. Because otherwise, you're like, what do I do? There's no identities with a 2 in it. So, with that being said, I will be on for a few more minutes, but that covers the 5 problems from yesterday. So hopefully that kind of gives you an idea where things are going. And I hopefully gave you guys some insight into, the hows and the whys of what words work and what I was thinking through it. So if you're math, what the math thinking behind it is, because I really don't want it to just seem like I'm just throwing, poof, there it is, and away you go. So if you have questions, obviously feel free to email me, but also email your teacher if you're not in my class. If people are complaining about this, they've got the video link here, which is also fine. We spent 54 minutes doing math. And that's also part of the reason why we're going to just try to keep these things down to 3 so you can play around with them. Now, I would also say if you've made it this far, good job. But I would also say that, really, if you're pushing more than a half hour at that point, submit what you have. Just because we're not intending for you guys to be spending probably more than about a half hour per class. So if this was a little bit, I know I chatted with a couple of you guys online yesterday that you guys are spending a lot of time on this, and I just said, submit what you have is good enough. We're trying to get you guys to play around with it, so don't panic about that. So with that being said, if there's anything else, let me know. But I think that's it. So next week we're going to go through and do a bunch of different types of review. Remember, tomorrow there's nothing specific that you have, so you don't have to check in for attendance. I'll probably put something up just to remind you about that. And so we'll see you guys on Monday. We will be posting stuff up on Mondays for you, and then Monday through Thursday of next week, and then Friday, because of parent-teacher conferences, you guys wouldn't have been in school, so you won't have to do anything e-learning-wise. And again, we're just trying to but anyway, for next week in terms of the review stuff, Ms. Thornton, Mr. Perez, Mr. Brooks, and I are kind of talking through some topics of stuff that we've done both in first semester and second semester, kind of go through and review, hit logarithms, probably the unit circle trig, and some other things just to kind of keep you guys on your toes. And as you can see from this, there's still a lot of algebra from first semester that you guys need to know. And so we thought we'd use that time from there. And then hopefully sometime during spring break week, we'll figure out when we get to go back and what the plan is from there. So, with that being said, I'm going to go ahead and hit the end of the stream. Shoot me an email if you need something. Thank you. Oh, and hit the subscribe button, like the video, etc., all those things that those gamers say. Thanks again. Talk to you later. Boom.